Welcome back, focused learners. Today, we are going to explore the absolute fundamental geometric concepts of basic plane shapes, specifically perimeter and area. Now, if you're taking your Cambridge 0580 exams, think of geometry like being a cricket captain. You need a solid strategy. You have to know exactly how to set your field, read the examiner's bowling, and score your runs. If you've ever looked at a shape in a past paper and wondered how to mathematically define its boundaries or the space it takes up, well, you are in exactly the right place. We are going to break these concepts down using clear, logical steps, turning abstract ideas into tools you can use with total confidence to maximize your marks.
So here is our game plan, our structural roadmap for today's explainer. First, defining perimeter and area, getting our core vocabulary locked in. Second, we'll tackle the rectangle perimeter formula, followed by Section 3, the rectangle area formula. And finally, we'll uncover something pretty cool, the triangle secret.
Okay, let's dive into this first section, defining perimeter and area. Because before we start calculating anything, we absolutely need to establish our core definitions.
Let's clearly contrast our two main concepts side by side, because examiners love testing if you know the difference. Think about perimeter as setting your field in a cricket match. It is the boundary rope, it's the total distance around the outside of the shape. Because it's a straight line distance, we measure it in linear units, millimeters, centimeters, meters, or even kilometers. Then we have area. Think of this as the actual grass on the pitch. Area is the amount of surface that the shape covers. Because it measures a two-dimensional surface, the units are always squared. Millimeter squared, centimeter squared, or meter squared. Keeping this distinction crystal clear is your rock-solid foundation for everything that follows. And hey, before we continue, subscribe to our YouTube channel IGCse Exams at IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, with our definitions perfectly set, let's move cleanly into Section 2, the rectangle perimeter formula. Let's look at how we calculate the outside edge for our very first simple plane shape.
What we're about to do brilliantly illustrates how mathematical formulas are built logically, not just blindly memorized. Let's picture a rectangle with a length L and a width W. In step 1, if we were to walk all the way around the outside boundary rope, we'd add the length, then the width, then the other length, then the other width. So your perimeter equals L plus W plus L plus W. In step 2, we can clean this up using basic algebra, which is a great habit for your exams. We group our terms together to get the perimeter equals 2L plus 2W. Finally, in step 3, we can factorize this equation by pulling out that common number 2. This gives us our elegant final formula. Perimeter equals 2 times the sum of length plus width, or 2 times L plus W. It's simple, it's highly logical, and honestly, it just saves us precious time during a test.
Now that we've totally conquered the outside edge, let's shift into Section 3, the rectangle area formula, where we focus on the internal surface area.
Here is our simple foundational formula for scoring those area marks. The area, represented by a capital A of a rectangle, is given by A equals LW. That's simply length multiplied by width. If you know exactly how long the shape is and how wide it is, you just multiply those two numbers together to find out exactly how much surface it covers. Easy, right?
Let's see this in action and break down a worked example. Our formula is A equals WL. But examiners love to throw a curveball. Let's say our known values are an area of 200 square centimeters and a length of 25 centimeters. We don't know the width. Well, we can plug our knowns directly into the formula to get the calculation 200 equals 25W. By algebraically working backwards, just dividing both sides by 25, we find that our missing width, W, equals 8 centimeters. It's a fantastic reminder that formulas work in multiple directions, so don't let it panic you if they give you the area first. And real quick, stop scrolling. Subscribe to our YouTube channel IGCse Exams at IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, moving on to Section 4, the triangle secret. This next part is genuinely fascinating. We are going to transition to triangles, and as you'll see, their geometric properties are intimately tied to the rectangles we just mastered.
First up, let's clarify the crucial geometric vocabulary needed to understand the anatomy of a triangle before we start calculating a single thing.
We have the vertex, which is simply a mathematical term for a corner point of the triangle. Then we have the altitude, which is much more commonly called the height. Now listen carefully, this is the straight line measuring from the base to the opposite vertex. Getting these specific terms straight in your head is essential for avoiding common traps in our next step.
I want to pose this key question directly to you right now. How exactly is a triangle's area related to a rectangle? Take a second to really think about it. If you draw a triangle completely inside a box, how much space does it actually take up? Let's see how this builds step by step to answer that exact question. Imagine a standard triangle drawn perfectly inside a surrounding rectangle. If we drop a height line straight down from the top vertex to the base, we split both the triangle and the rectangle into two smaller sections. If you just look at the left section, the smaller triangle inside there is exactly half the area of the smaller rectangle it sits in. The exact same is true for the right section. The triangle part is exactly half of the rectangle part. So think about it. If the left part is half and the right part is half, the unavoidable logical result is that the entire central triangle is exactly half of the total surrounding rectangle. It's a really beautiful, intuitive visual proof.
And because of that brilliant logical proof, we arrive at our earned conclusion. If a rectangle's area is base times height, and a triangle is exactly half of that rectangle, then the area of a triangle must be A equals 1/2 BH, half the base times the height. We didn't just blindly memorize it from a textbook, we actually proved it. Now here is where students lose marks. The absolutely crucial point is captured perfectly in this quote from the source text. It does not matter which side is called the base, but the height must be measured at right angles from the base to the opposite vertex. You can rotate that triangle in your exam paper however you want. Any flat side can be the base, but your height cannot be a slanted side. It literally must drop straight down at a strict 90-degree right angle from the opposite corner. That is the golden rule of triangle calculations. Never forget the 90-degree angle. We've covered some incredibly valuable ground today, laying down the absolute foundation of plane geometry. But I want to leave you with this final provocative thought. Think about an intricate, crazy-looking polygon with 10 straight sides sitting there on your exam paper. If you look closely enough, complex polygons are really just simple combinations of rectangles and triangles stuck together. So how could you use these two basic formulas, just the rectangle and the triangle, to break down and find the area of literally any straight-sided shape they throw at you? You have the tools now. It's just a matter of putting the puzzle pieces together and scoring those runs. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.